everyone. My name is Wei Zhang from Alibaba Cloud Container Service Team. I would like to talk about serverless Kubernetes container in the cloud-native way. I will have a half-hour presentation to introduce serverless and some of our practices in serverless containers and its progress and development. I'm also going to talk about a demo and show you a demo if time allows. I'm going to talk more about questions and answers. Thank you so much for sparing your time to attend the last day of the KubernetesCon conference. And this room is also very hard to find. So thank you so much for coming here. First of all, let's have a look at the IT structure, architecture. First of all, in the IT architecture, how to deploy the cloud. I think you are very familiar with this chart. At the very beginning, we have the VM. And before that, we have physical machine. From physical machine to VM. In 2013, 2014, the whole industry has shifted to container. At the same time, we also saw the function computing and container are like the new formats for function deployment, application deployment. As we can see here from the chart, the container compared with VM, the innovation is like VM to physical machine. So the technological evolution will not stop. The innovative technologies are not from the scratch, from 0 to 1 or from 0 to 2. It is like a combination of different innovations. For example, the Docker container is based on a combination of basic technologies. In the newest community, they are getting mature. They have based on C group and other primitives to form some new innovative technologies. So today we talk about serverless. It is also a kind of a combination of innovations. It combined container and serverless into one. Why we need to combine serverless and containers? Because they have different features. For example, for container, it has a consistent deployment and execution. It has a fast delivery and agility. For serverless, the users do not need to concern about server, so they don't have to consider the maintenance and operation anymore. Serverless plus container for IT DevOps or maintenance, this is actually a very new innovation and trial. Service container in the whole industry has many vendors. Since 2016, we witnessed Hyper, the first vendor for the serverless container. They have launched a very simple basic dock. You don't have to care about the container's operation. You only need to install the dock. And also we have Azure ACI, launched in 2017. At the very beginning, it didn't support Kubernetes or virtual Kubernetes. I will talk about this more. And AWS Fargate is based on ECS orchestration. It was planned to launch in 2018 for supporting the Kubernetes and the serverless computing. And now we have Huawei CCI, launched in February this year. We also have Alibaba Cloud Serverless Kubernetes from Ali Cloud. Now we are planning for commercialization. Now it's free for public test. Now let's compare serverless Kubernetes and the traditional Kubernetes clusters. For traditional Kubernetes clusters, no matter for the users, they can deploy the clusters in the cloud in a very faster way. So this is a very classical Kubernetes structure because they have a mask and a worker. For the mask, they have different types of deployment. For example, the user can choose their exclusive master version. They can follow up in Estes. The master is for the user clusters. the user can totally control the capacity and the clusters. And another one is a trusteeship. So all the DevOps, maintenance, upgrade will be done by the vendor. However, both of them have similar structure. They need to have the work node. The work node should be a virtual machine or a physical machine or bare metal server. The port should be on the work nodes. So this is a very classic cluster for Kubernetes. For serverless Kubernetes, we can see here, it also has the container scheduling orchestration. And this is actually outside of the clusters. The users cannot see it. They don't have to care about where is the master. However, the difference is here in the cluster. They don't have work nodes. The port, the user can only see the port. They didn't know where the ports are deployed on which work node. But they also cannot see the node. So this is also a very classic and a very visible difference between the two. In the service cluster, the users cannot see the node, so the port is based on the demand. So they don't have to deploy the work nodes. And their payment is actually very different from traditional one. In the serverless Kubernetes, their port is actually, for example, you deploy a Linux. When you start it, you will pay on the demand. And after you terminate the usage, you will stop payment. However, for the classical one, it's different. Your payment is actually based on your nodes. Starting from the deployment of the cluster, you pick 10 work nodes. On that moment, you start to pay money. No matter whether you have deployed port or applications, the payment is permanent, cannot change. Only if you eliminate all the ports and the clusters, you then can stop payment. So the payment model and the payment template are quite different. So the traditional one is based on the node for payment. The users need to be very cautious about the scale, the size of the work nodes. For example, for CAG or different sizes and scales have different fees. But for the serverless Kubernetes, you don't have to choose the size of the nodes. You have to choose one size, but the size of the port is something you need to choose. You also need to set the CPU and the language for the port. For example, the CPU can be 1, the language can be 2G, the memory can be 2G, and then the payment is based on the choices of the memory and the CPU. Many users have ignored one part. In the traditional, based on the node payment model, your node capacity should be over than the port capacity. If your application only needs to use 1 CG, you don't have to create a work node based on that. You have to create a work node more than that. You need to prepare an idle resources for preparation. Otherwise, if it is full, the port and node have the same resources will cost the port will be overloaded. So this is a very huge difference. But for service capacity, you don't have a redundant resources. All the resources your port use, you can just give it to them. You don't have to give them redundant resources. So for different deployments, it will have different cost for you. When you compare it, the users need to be very cautious about the differences. For the traditional capacity or Kubernetes, you need to have some idle resources, some redundant resources, you never will use it. For example, the 15% of the clusters are actually used, and 85% of the computing resources are actually wasted. And in this Kubernetes and serverless addon node, we also have 6 types of serverless. For example, we call it service addon. Compared with the Kubernetes and Serverless, it is quite different. In the Serverless, it is a very complete cluster. The users cannot see any workload. However, for those existing users, they already have the capacity cluster. They already have a lot of nodes. At this time, they want to use the serverless flexibility function. How can they do? They don't need to create a new serverless cluster. In theory, you can use the same VPC for the traditional one and the new one. The pod is connected. And another way, well, in this way, for the multiple clusters, you need to manage the multiple clusters. However, if you use serverless add-on, you can use your old plus a virtual node, and you don't have to create a new cluster based on your old capacity. You can add a virtual node to add its flexibility and the scalability. For example, here we have 3 nodes. They have limited computing capacity. If your service is like an e-commerce, in the Double 11 day, the shopping festival, you need to use more pods. You need to scale out. And you don't want to buy too many nodes or the ECS or node, then you can use the virtual nodes to satisfy your sudden huge demands. This is actually a real case. In the Double 11 day, our shopping festival just finished several days ago. We have some customers using this kind of way to add the virtual nodes. This is a very simple way to do that. You don't have to care about the node management, or you don't have to return the nodes or eliminate the nodes after the Double 11 day. So this is a huge difference. For the virtual node, the technology is also called the virtual tablet. Yesterday, we have a keynote from Azure. It is the Kubernetes founder. He talked about the node Kubernetes. This is like a very basic technologies for it. And here, this is virtual Kubernetes. We have a lot of providers, for example, Azure, Fargate, and other providers, and also have some dynamic pod resources. In this one is the ECI flexible container instance, elastic container instance, ECI. So from the virtual node, the ECI is actually the same with the real node. So you can have a cluster IP service, you can have an ECI pod. So in the real instance, you can also send any information on the virtual node. This is connected with the real node. It is the same. Well, overall speaking, via the virtual nodes, you can actually provide some unlimited elasticity and flexibility based on the already existing nodes. So now I'm going to talk about Kubernetes and serverless add-ons. So here are the features for it. The first one, you don't need to have a managing service. Once we launch these technologies, many users are very interested in it. Their first demand is not to manage the service, because before they used the virtual machine to deploy the services, and many users think it's very difficult. So they want to use the capacitor, this very Kubernetes is very simple for them. They don't want to even see the ECI servers. So the serverless and the Kubernetes can satisfy their demands. Without servers, they don't have to do the capacity planning. They don't have to care about node. They don't have to care about the GPU or granularity. They don't have to care about anything. They only need to focus on their own applications. They don't have to purge any complicated management tools or networks, because their serverless and the Kubernetes created the pod. Once the pod are created, they have VPC IP. They use inline network, and the network is actually better than the KBAS. And also the choice of the operation system, you don't have to care about it anymore. Also very important in the serverless, you don't have to manage the operation systems upgrading and anything, maintenance or patchy or like monitoring or maybe CV bug, because you don't have any servers. and all the tasks that IT from one company, they don't have to care about it anymore.
But the serverless, for users serverless, but of course the pod will be running on the server, but it is hosted. Therefore, you don't have to care about the update and maintenance. So in a serverless scenario, the users only need to focus on their application. They don't have to do other complicated work. Now, it is and with the serverless architecture, you can also scale your pods elastically. If you use the node-based Kubus, if you have this kind of experience, you know that you need to expand the nodes, and then you can expand on the pod. The number of nodes and the capacity of the node decide the upper limit of the cluster. Therefore, if you want to increase the upper limit of the cluster computing, then you need to increase the number of nodes. But in a serverless scenario, because there's no load, so the logic is very easy. You just need to do the deployment. So the user don't have to do any reserve the capacity. And I want to emphasize the unlimited capacity. In this concept, ideally, the capacity is unlimited. In one cluster, if you can support the 10,000 or 100,000 pods, then you can support it. But of course, in the practice, you need to pay attention. You still need to consider storage. But ideally, you don't have to concern too much about the capacity. According to the logic, the capacity is unlimited. And then pay for demand. In the serverless architecture, the CPU and memory has a very flexible choices. And currently, we support a CPU from 1 to 8. And for different types of CPU, you will have different options for memory. For example, from 2 to 8, and other options. So you can adjust the resource utilization of the pod in very fine granularity. Because there are different resources, the cost will be different. We designed in this way because we want to improve the cost performance. Because previously you need to reserve up a certain amount of computing resources, but in serverless, you can configure only pay for the demand. And in the serverless, it is compatible with the Kubernetes native API. For example, for the workload, it can do the deployment, stateful set, job and bear pod, and you can be connected to VAS, and it can support other technologies as well. And for the service discovery, we use the 2.0 private zone to do the service discovery. And you can find the name of the service and IP of the service in the private zone. And for ingress, we use Alibaba 7-layer load balancer and the volume. And we also will support the logs EICC, HPA. And HPA is very useful for the elastic environment because it can support the customized demand. And now I'm going to introduce the architecture design of Cloud Scale. It's very different from traditional one. We also have the Kubernetes API, and the core part is a Viking. Viking can conduct the enhancement for the service and listen to the service and the resources. And the Viking will listen to the pod to see the changes. If you want to establish the pod, it will call an API to create a pod. And in the pod of the ECI is a logic entity, and there's a VM, and it can have a Viking agent in the VM. It's very similar to Kubernetes. It can call your pod. Of course, there are many containers, and we will call the container, and also have a Docker mode, and it's a very lightweight. Speed will be fast, and later maybe you can have a try. The most important component architecture of it is because Viking can listen to the changes of the pod and can continuously create ECI, and ECI is decided by storage. So in the process of creating the ECI of the Viking, the process is not limited to the nodes. It's only limited. The only limitation is the storage of the ECI. So we don't have to depend on the node. Maybe the node is 96C. In this architecture, there's no limitation. You can create pods unlimitedly. 1,000 pods is possible, and they can run in parallel. So it's very different from traditional ones. At the same time, in the architecture, our pod is deep integrated with the cloud platform of Aliyun, the Ali Cloud. We have a Viking agent here, and the network of POP is connected with the user VPC. You can visit RDS in the VPC and also NAS, OSS, and SLS in the user VPC. And through the VPC, you can visit some official websites or the container registry. Now we will have the serverless Kubernetes use cases, and in what condition the user will choose this kind of product. As I mentioned, and because the user don't have to manage the servers, and the advantage is its elasticity. So there are some multimedia processing, or some unit driving, event-driven scenarios, and sometimes the functions will have limitations. For example, it can only run for 10 minutes, and it has a special requirement for the language. But in the container, you can operate or run any application you like. You can write this application in any way. So it's very different. And also in the chatbots, or the stream processing, and some mobile backend also very suitable for this technology. And also has RCI/CD and also the data processing. Actually, data processing requires a very elastic scenario, because you need to compute this data in a very short time, and then you need to release the results after the computing. And in this scenario, the serverless Kubernetes is a very suitable solution. And now I'll give you a very brief demo. I use a serverless Kubernetes to establish a service cluster very quickly, and also to do some smart data handling. And firstly, we'll open the Ali Cloud. Well, I don't know why my screen cannot be projected. So this is Ali Cloud service, and it can provide different deployment mode, and this is a special. And you can choose the cluster name and also the geolocation. It has different configurations. And you can choose the master or the worker mode. And there's a 4G and 8G, and also by default, the number 3, and you can change it according to your demand. This is a traditional cluster, and there are also a hosted cluster. The difference is that there are only one configuration, which is worker mode. There's no master mode because master is hosted. So compared to the other one, I think the hosted one is more acceptable for the public. If you want to deploy a cluster by yourself, you need to afford the cost of the master. Now here, you can choose it and then choose the geolocation, and then you can create the type RPC automatically, and then you can have the service discovery function in cluster. Actually, after you're creating this cluster, you don't create any nodes. So it will achieve. It takes about 5 to 6 seconds because you need to create a VPC and vSwitch. It takes some time. Okay, it's successful. The reason why it created very quickly is because it doesn't create any nodes. Now click on Manage, the management, and in the management tablet you can have a certificate here, and you can use this certificate to go through the control. Now we can save the certificate we just copied, and then set up the environment variables. Then you can use it. Now we can operate the cluster now. As I mentioned, this is a serverless cluster. And now we can look at the node. Actually, can't see any node. You can see the deployment and the pod, but actually the user don't have to care about nodes. Now we can deploy a Spark cluster. Spark cluster is easy, and this is you can create a web UI 8080 port. And this is a headless service. And there's 2 deployment. One is for master, and the other is for worker. And how do a worker register with master? You can use service discovery.
And this one is master worker node. Working node is creating now. It's still creating. In many scenarios, it didn't take such a long time, maybe around 8 seconds. However, maybe some of the reasons the pool is not enough. That's why it takes 20 seconds to create a container, to become a container. Now I'm going to pull in the image. Through the controller, we can also see the deployment and creation. This one is manager, serverless. These two deployments are created successfully. This one is already in the running. The Spark Web UI, the interface, we can see it via our controller, our web browser. You can see your Spark cluster you just created. Here has a worker IP. This is the worker IP. After we create the cluster, we can go into the cluster. We can access the cluster. We can go into the worker. This is a Spark Summit, and then can also submit any tasks for data management, data processing, when we want to scale out or expand it. For example, if your data amount is very huge, you need to scale out your work nodes. It is also very convenient. You can Okay. This is now running. In the controller, you can also see the workers. Now let's go back into the worker again. Let's see in the worker container how to access the master. This is a very classical and capacity cluster, the service discovery function. So this is the demo. Now the Kubernetes and the Serverless is still in the trial. We plan to launch it and open it for the users in December. Here is the controller and also the demo and reference. Thank you so much.